In the previous class, we were looking at two-port representation of networks and how to calculate some things in a circuit in which a two-port is embedded and you are given the two-port parameters, right. So, first we have the Y parameter representation, let us say. And we also have the circuit form, circuit representation of this, in which we have a conductance Y11 at port 1, Y22 at port 2, Y21 V1 and Y12 V2. Okay. And we also looked at three other types of parameters, which are Z parameters, where currents are the independent variables and voltages are the dependent variables. Okay. The Z parameter matrix is like the resistance, and this is like the conductance. Okay. So, what would be the circuit equivalent of this? What do you have? If I want to form a circuit that is represented by these Z parameters, what should I do? So, here we have the current as sum of two components, Y11 V1 and Y12 V2. Okay. So, one of them is represented by conductance, the other one by a voltage controlled current source. In this case, we have voltage to be sum of two voltages, Z11 I1 plus Z12 I2. So, what should I use to represent these? Yeah? Yeah. Firstly, I have a resistance. What is the value of the resistance? Z11. So that when a current I1 goes here, you have a voltage drop I1 times Z11. Okay? And in addition to that, you have a voltage drop. How much is that one? Z12 I2. Okay? Similarly, here we have a resistance Z22 and Z21 I1 as the control source. Okay? I1 and I2 are the currents in the two ports. V1 and V2 are the voltages across the two ports. Okay? Very simple. I mean, for each term in the two-port parameter description, you have either an impedance or a control source. Whether you have an impedance or a control source depends on whether the voltage and current are across the same, I mean, of the same port or different ports. Okay? And this is quite simple, so we can form it for the other two parameters also. We have V1 I2 to be H11, H12, H21, H22 times I1 V2. Okay. Any questions here? So, how would you represent this? How would I represent whatever I need for port 1? Huh? Okay. And there is a resistance H11, okay. Yeah, we need a voltage controlled voltage source, because this, the value of this is H12 V2, where V2 is the voltage across the second pole, okay. And on port 2, we have a current controlled current source. What is the value? S21 I1, where I1 is that way, and a conductance H22 in parallel. I will write H22 here. H22 has dimensions of conductance, so that is what that is, okay. And G parameter is simply the inverse of this. What is the relationship between the H parameter matrix and the G parameter matrix? Huh? Is there any? I mean, if I gave you the 4 H parameters, how would you get me the 4 G parameters? Inverse, that's all. So, if I take it to this side, then this becomes just the inverse, okay. And similarly, we already saw that these two are also inverses of each other, okay. And here I would have a parallel combination of conductance G11 and a current controlled current source G12 I2 for port 1, and the opposite, a voltage controlled voltage source G21 V1 in series with a resistance G22 for port 2. So, as I mentioned earlier, I will simply mark either the conductance or the resistance. You take it to be whatever is the appropriate one, okay. Just a quick note on why have all these different types of parameters. It is just a matter of convenience, okay. Depending on how this is used in a circuit, it could be that some representations are easier to deal with than others, okay. For instance, let us say I have a network N which is 2 port. Then what I do is I have a couple of components in addition, okay. And this whole thing is my composite 2 port, let us say A prime and B prime. Now, given the way these things are connected, tell me which parameter set would be easiest to use, so that what I want is 2 port parameters of the new network. That is the new network which is between A prime and B prime, okay. This can be done with every one of the 4 sets of parameters, right. You can always do the calculations, but just look at it and tell me which would be easiest, which one you could kind of write by inspection. H parameters. Why? Clearly, with H parameters, what you have is a resistance here of H11 in series with a voltage controlled voltage source, and a current controlled current source in parallel with H22. Okay. So, all that happens is this H11 becomes H11 plus R1, right, nothing else changes, and similarly H22, what will that be? Yeah, H22 plus G2. Okay. G2 means 1 by R2, that's it. Okay. So, it is just a matter of convenience. Of course, it can be done with any set of parameters. Okay. So, this is the reason to have like different representations. Some of them are one is of course convenience of calculation, and sometimes also you have different sets. Some of them may reflect the sort of physics of the situation better than others. Okay. Although all of them equivalently mathematically they describe the same. Any questions so far about any of the two port parameters? Okay. Now we can go to general properties of some types of two ports, but before that let me I want to point out some other things. So, let us say I have the Y parameter description. Okay. What I want are H parameter and G parameters of the same network. That is, I want H11, H12, H21, H22 in terms of the Y parameters. Similarly, G11, G12, G21, G22. So, please do it, and I think this again is some sort of a routine calculation. So, maybe half of you, these two rows, please do G parameters and the remaining 3 do H parameters. After that, I want to point out some things in the way the parameters come out. Okay. So, for Z it was easy, it was just the inverse of the 2 by 2 matrix, which we could write down by inspection. These things are also easy, but maybe take a few more steps, that is all. This is what the first equation says. So, if I take V1 to the left side, I would get similarly, so in this case we get V2 to be what's that? Yeah. So yeah. Okay. So in fact the H parameter matrix came out to be 1 5 by 1 1, right? And G you can this is now terminated in a short circuit. Okay. So what is the value of V2 in this case? What is V2? 0. So this control source goes away, right? So this current simply flows into Y11. So what is the voltage V1 developed across port 1? I1 divided by Y11. Y11 is the conductance, right? Yeah. Multiplied. No, it's the current divided by conductance is voltage. Okay. So obviously this is Y21 times V1. So you get Y21 by Y11 times I1. Okay. So it's also easy to see in the circuit way. I mean, all this is not a big deal. I mean, if you find it in the equations or this way, but it just tells you why the circuit viewpoint can be important. Okay. So all that happens is this current gets converted to a voltage across this resistor, and then that voltage gets converted to current through this transformer. Okay. So that's why you see Y21 by Y1. Okay. So you can form these, I mean, you can convert from one to other. I will take it as a G1. Right? You should be able to do these calculations without too much difficulty. Any questions so far? Now there is one more interesting thing here. So let's say Y12 is 0. Okay. Y12 is 0. So what does it mean? If this is 0, so that means that V2, the voltage connected to the second port, has no influence on I1, the current that is flowing through port 1. Okay. Is that fine? If Y12 is 0, what can you say about the H parameters and the G parameters? If Y12 is 0, I mean, just look at the expressions, right? What H12 is 0 and G12 is also 0, right? Yes or no? I mean, Y12 is right there, right, in the numerator. I mean, if Y12 is 0, H12 will be 0 and G12 will be 0. What about Z12, the Z parameters? Z12, it will also be 0, right? If you think of the inverse, all that happens is that would have been negated and divided by the determinant. So that will also be 0. So is this some, why does this happen? What does the parameter 1, 2 being 0 mean then? Yeah, basically that means that the circuit is unilateral. The control flows only in one direction. Okay. If you connect something to port 1, it affects port 2. But if you connect, I mean, whatever is on port 2 side will not affect port 1. Okay. So now, of course, it doesn't matter which parameter set you use to describe it. If it is 0 in one of the parameter sets, it has to be 0 everywhere. Okay. That just is representing the reality that port 2 doesn't have any effect on port 1. Okay. So the control goes only this way and not that way. Is this fine? And unilateral 2 ports are very important and interesting in amplifiers. Okay. I mean, all the transistors and other active things are almost unilateral. In fact, you would like them to be completely unilateral, right? That would be the best. And I'll assume that Y21 is not equal to 0. Otherwise, it's just two separate circuits. If Y12 and Y21 are both 0, it's just two resistors on the two sides, right? There's nothing interesting in this at all. I mean, there's no meaning in even calling it a two port. So, if Y12 is 0, then first of all, this means that Z12 is 0, H12 is 0, and G12 is 0. Basically, what it means is that whereas port 1 influences port 2. Okay. So this is known as a unilateral 2 port. In a unilateral 2 port, Y12 is 0 and Y21 is not 0, or of course you can have Y12 not being 0 and Y21 being 0. So that means that the control only flows from port 2 to port 1, but not the other way around. Okay. That also you can see from these relationships, right. So you see Y21 here and there. So if Y21 was 0, then H21 would be 0, G21 would be 0 and Z21 would be 0. Okay. So this is known as a unilateral 2 port, and in lot of cases it would be very useful to have unilateral nature, that is control flowing only in one direction. Okay. In fact, having the control flowing backwards can lead to all kinds of problems. First of all, design can become complicated, it can lead to instability and so on. Okay. And the simplest example again is the amplifier. I would like it to just take the microphone input and then send it to the speaker, but nothing should come back from the speaker to the microphone. Okay. That would be the best. Now of course the amplifier itself doesn't send something back from the speaker to this, but if the whole system, because the speaker is putting out sound into the air, that can come here. So if you include the system as amplifier plus all the air surrounding it and so on, it will have some Y12. Okay. So that is the problem. If Y12 becomes sufficiently large, you can have instability, and this is again very familiar. If I go and stand there with this mic, the whole thing will burst into oscillation, right. This happens so many times in badly placed sound systems. So that can be one of the problems. If you have unilateral stuff, you are guaranteed not to have such things. Okay. The other thing is that if you, even if there isn't outright instability, like for instance, if you have unilateral 2 port, then the impedance looking into port 1 doesn't depend on what is connected here, right. Because whatever you connect, nothing is, there is no backward flowing control, right. So if there is Y11 here, the resistance looking into this will be just 1 by Y11, regardless of what is connected. But if you do have a non-zero Y12, what happens is, depending on what you connect, the resistance looking will be different. Okay. So now if you have a chain of blocks, it becomes very complicated to design, because the first one has to drive the second one, but exactly what it is driving depends on what is the third one, which probably also depends on the next one and so on. Okay. So the whole thing becomes a lot easier if things are unilateral. Okay. So in courses like signals and systems, when you draw these dabbas with arrows like this, it's assumed it's unilateral, right. You have some x here that gets multiplied by some h and you get x times h. There is no backward flow at all. Okay. But when you try to make real systems, it's actually quite hard to do this, and in some cases may be impossible. Okay. Things will go backwards, and then all the nice signal flow graphs and block diagrams that you see on paper may not be realizable. Okay. Any questions about this idea of unilateral nature of 2 ports? Unilateral, I mean, as the name suggests, it means that the control is flowing only in one direction. So either Y12 should be 0 or Y21 must be 0. Okay. And it of course means that if any of the 1, 2 parameters is 0, all the others will also be 0. Okay. Any questions? Yeah, it is possible. Nothing will happen. Yeah, so that means that the input resistance is infinite. It is an open circuit. Right? That is okay. I mean, exactly what circuit will give that, let's not get into it, but it's possible. Okay. Similarly, Z12 can be, Z11 can be 0, so that means it's a short circuit and so on. That's possible. Any questions? Just one remark about two ports. I already mentioned this earlier. So we represent two ports. So far I have shown a picture like this. So this means that the port is here. Let's say we connect voltage sources and there. Okay. Don't treat it as some arbitrary 4-terminal device. That is, you are not allowed to do things like this. You shouldn't connect like one more input like that. If it is a 4-terminal network, you can do it, but in a 2-port, the definition of 2-port means that you apply the input between 1 and 1 prime and 2 and 2 prime. Okay. So this cannot be done. Now, if you consider a 3-terminal 2-port, where essentially terminals 1 prime and 2 prime are identical. Okay. So it is the common terminal, and 2. Then this problem doesn't arise. There are only 3 terminals. You can only connect 2 sources independently. I will define something as the common terminal, that is 1 prime and 2 prime. This will be 1, and I connect the first one here and the second one there. There is no place to connect the third one anyway. So there is no such ambiguity. Things will be a lot more well defined in this case. Okay. So whereas in this case there is no issue. So for simplicity now, let us take a 3-terminal 2-port. And all I know is that it has only resistors in it. Okay. There is nothing else. There are only resistors in that. Okay. What could you say about the 2-port parameters in this case? Can you say anything at all? What is that? What will be in parallel? No, there are only resistors inside, but I don't know how many. There could be 1, there could be 1000. So can we make any general statements about Y parameters, let's say, or Z parameters? What is that? Y12 and Y21 will be 0. Why? That's true. Okay, so maybe before going here I should have asked you to calculate something else. This is very easy to calculate, so please do this. This is a 3-terminal 2-port, right? 1 prime, 2 prime. Calculate the Y parameters for this. So what do you get? Some of you have got it, some of you have made all kinds of mistakes. So if you short circuit this, okay, you can apply a voltage here and find the current flowing this way, that is I1, and here you have to find the current flowing in this direction, that is I2. So this will give you Y11 and this will give you Y21. Okay, and similarly by shorting the other side, shorting port 1, you will get the other 2 parameters. Okay. So I see a lot of mistakes in calculations and so on, some simple mistakes. This is a relatively simple circuit, so you should be able to do this correctly. And once you do that, please look at the numbers that you get and see what pattern you have. Of course, we have just taken one particular example, but we can try to generalize from there and then see what properties you see in the y parameter matrix that you have. Okay. So, we will continue the discussion from there in the next class.